Our second speaker in this geotechnical issues session is Geoff Cox. Geoff is Senior Principal with Coffey Geotechnics and probably has over 40 years experience, I would say, in the geotechnical world. And Geoff is going to talk to us today about foundations for residential buildings.
Okay, so I'm going to be talking about the effects of sand fill on groundwater, sand fill and groundwater on foundations for residential buildings. The basic requirements for the footings for a residential building come from an Australian standard, AS 2870, residential slabs and footings, and it works on a system of what's called site classification, where sites are classified according to the expected amount of soil movement from shrink and swell of clays. So we have Class A sites, which are your well-drained, dense sand site, where soil movement is expected to be negligible. We then have Class S sites, where soil movement's expected to be less than or up to 20 millimetres. And typically in Perth, that'd be a site where you've got, say, 0.8 to 1.2 metres of sand fill or natural sand over Guildford clay. And this idea of putting sand fill over everything is very much a West Australian and Perth idea. I had, just by coincidence, had a phone call from a colleague in another Coffey office in another state. He said, you know, developers come up with this radical idea of putting sand over the clay. Do you think it'll work? So this is very much a West Australian solution. And then you have moderately reactive clay sites with movements between 20 and 40 millimetres, and the scale continues up to Class E sites with more than 70 millimetres, which we don't fortunately have many in Perth, though you do get them in some rural areas and pastoral areas in Australia. Another important part of that code is a requirement of what's called the bearing capacity. How much load can the soil carry without there being a shear failure? And we work with fairly generous factors of safety with this, but the code requires for a Class A type footing, where the strip or pad is not tied to the slab, to have 100 kilopascals of bearing capacity. There's a very simple expedient to solve that. You tie the footings to the slab, and then you only require 50 kilopascals because the footing can't move very easily then. For a double brick single-storey house with standard footing details and Australian standard, though our colleagues from Structair and other companies have developed, I think, more efficient solutions than some of the solutions that are in the Australian standard. But a Class A footing's about 300 millimetres deep. A Class M footing, which is what you'd have for a double brick building on clay, on a moderate reactive clay, is about 800 millimetres deep. But I believe structural engineers here have developed more efficient solutions. Soil movements based on shrinkage and swell of the clay. Well, the site classification that's used is based on that. If the movement's from other causes, say consolidation of a soft clay or a peat or something like that, then the site would be classified P. Site classification is affected by the clay reactivity, how much it shrinks and swell, and the depth of the soil suction change, how much of the soil profile does the moisture content change in, and that in turn correlates with the climate, which is characterised typically by a thing called the Thornthwaite Moisture Index, which in turn is related to rainfall and evaporation. So we get the biggest depth of soil suction change in hot arid climates. So if you're out at Halls Creek or something, you might have a soil suction change of 4 or 5 metres. If you're down at Augusta, cool, temperate climate, might only be 1.2 metres or something like that. How does the sand influence what we do? Well, the sand's non-reactive, so it doesn't shrink and swell. So that portion of the soil column within that depth of soil suction change is reduced. So the top bit, which would have the greatest moisture changes, is non-reactive now if we put sand over it. Another effect which we there's no provision in the Australian standard to allow for, but sand will allow more rainfall to infiltrate. So effectively, we will be emulating a wetter climate. Sand can also have an effect on the evaporation from the soil. The typical soil capillary rise in sand's only about 300 millimetres, maybe 500 for some. The sands, the bit richer sands in Perth. So that means that it's a bit harder for the moisture to get to the surface to be evaporated. So in effect we emulate we get two effects. We get non-reactive soil cover, and the Australian standard allows us to calculate for that. It also emulates a more humid climate, but there's no provision to allow for that in standard analysis techniques. So what's the effect of sand fill on site classification? It's pretty and relatively easy to go from an M to an S with sand. You need about typically 1.2 or 0.8 to 1.2 metres of sand fill. The minimum allowed in the Australian standard is 0.8 if you want to reclassify. So even if your calculations show that you only need half a metre, the Australian standard says you've got to have 0.8 before you can make a change to the classification. Going from M to A is a bit more difficult. There's no consensus amongst geotechnical engineers as to whether that's valid. If you were to ask 3 geotechnical engineers in this room whether that's valid, you get 5 different opinions. So it's not something that everyone agrees can be done, but if it is going to be done, we probably need somewhere between 2 and 2.5 metres of sand. So it's quite a big amount of sand if we want to go to an A classification. There's also provision in the code. The way Australian standards are developed, they're always a compromise, and Western Australia has its own special detail in the Australian standard, a lightweight A classification footing detail. I'd say that that's not appropriate if we're putting sand over clay to reach the A. So what about climate change? Well, Perth's climate is now more arid than it was in the 1940s. If this trend continues, the depth of soil suction change has increased or will increase. That in turn means that we're likely to need more sand fill, a greater thickness of sand fill to achieve the same sort of upgrade in site classification than we did in the past. But we need to recognise, particularly if we're talking about groundwater levels, that just because we have a drying trend, we still do get wet years. So, for example, Busselton had I'm not sure if it's wettest, certainly one of its wettest years in the 1990s, and Albany's been having quite a run of wet years in recent years. So Albany doesn't seem to be drying to the same extent that Perth is. So what does groundwater do to bearing capacity? Remember we talked about if the strip footing's not tied to the slab, we need 100 kilopascals. Well, I've got some complex calculations for Deborah's benefit. She likes those. So I won't go through why I chose those parameters, but when you look at bearing capacity, you look at the width, the depth of embedment of the footing, the soil properties, whether the load's centrally located on the footing or slightly eccentric, whether there's some horizontal load from wind loading and those sorts of things. And if we consider depth measured below the base of the footing, we end up with a graph like that. So when the groundwater gets within about 0.3, 0.4 of the base of the footing, then the bearing capacity starts to decrease. However, there's still a margin there. Remember, this is for an untied footing. And you'll see we still have 100 kilopascals when the water reaches the base of the footing. So we shouldn't let bearing capacity be the main constraint on how much sand we need or other solutions. This is not a problem with the footings on clay because they are in themselves much deeper, and the greater embedment depth solves the bearing capacity problem. So we start to have an effect on bearing capacity with a Class A footing on sand when the water's about 0.6 to 0.7 of a metre down, but it can get much higher, and there's a pretty simple solution, which is tie the footing to the slab, some crank bars and it's not really a problem. Perching of groundwater on the clay and mounding between subsoil drains. We need to remember when we're looking at these things that it's not, the groundwater level is not the same as the depth of the subsoil drains. If we put subsoil drains in, there'll be mounding in between. For those who like playing around with dimensionless solutions, with a colleague, published some dimensionless solutions where we can work out the height of the mound for different combinations of permeability and soil spacing, subsoil drain spacing, and depth to the impermeable layer. So some construction considerations with sand fill. One of the reasons developers like it and builders like it, or particularly builders like it, Australia. Trafficability is easier. It's easier to move around on a sand site in wet weather than it is on a clay site. I can recall in my younger days I had a house in Kelmscott on the Scarp, some lovely high plasticity clays, and I used to grow about 50 millimetres in winter when we were doing the gardening with all the mud built up on my boots. And the house construction service trades in particular, like the sand, they want to dig down about 600 millimetres for a lot of the services, and it's pretty easy to dig the sand and then put it back in the trench. It's a lot easier than working in clay. Some ways we could consider to reduce the amount of sand fill required if we want to keep having backyards that we don't get mud on our feet, like walking around. Well, we could put subsoil drains along the rear of the lots, and I'm sure there's those who'll say, well, that's going to be really difficult in terms of maintenance, and I accept that, but it is a technical solution. We can use mixed systems for soak wells. Instead of putting enough sand there to be able to use soak wells, we could have soak wells to take the first flush of the storm and let the overflow go to the pipe drainage system. Very simple expedient of tying the edge footing to slabs reduces we can allow the groundwater to be much closer to the footing, and we could just use class S footings rather than A, and we'd halve the amount of sand we need over clay sites. Some of the effects of reducing or eliminating the sand fill, well, you know, what you save on the sand, you're going to pay some of it at least in extra concrete and steel, and certainly the trades in Western Australia are not set up to do something like Class M footing. You ask someone to dig a trench 800 mil deep and put steel in the bottom of it, and they all go, ooh-ah. Even though we do it in other states, but we've got a system in Western Australia and everybody can dig a trench 300 mil deep, and it's easy. Certainly get increased surface runoff if we don't have sand on the surface. Clay will shed more water in a rainfall event, so that'll mean that the pipe drainage in the road system might need to be larger. Less infiltration might lead to lowering of the water table. The present system is quite good at getting water into the ground. Less amenity, flooded and boggy cracked backyards. Our system of fencing, where we often have brick fences, etc., that are becoming popular. They're sitting on clay, they'll cut off the surface runoff. So these are all the things, if we make a change, we've got to change a lot of things. It's not just a question about, oh, we'll increase the footings of the houses. We have to change the type of fencing we use. You can get disputes between neighbours. There's a court case coming up very shortly about on this issue. There's obviously going to be a savings in sand cost. The net effect, though, is that a lot of the costs are transferred from the land developer, who pays for the sand, and those costs are now borne more directly by the builder and the owner. So my thoughts on the matter, I think we need to consider all of the costs. We can't just think about, well, sand's expensive. We've got to think about the effect on road drainage, use of soak wells, amenity, fencing, environmental, etc. I think the amount of sand we need to go from a Class M to an A is just too much. I don't think it's necessary. We can build quite reasonable houses on Class S footings and halve the amount of sand with that simple expedient. Thank you.